are either kind of in the wild or in our pre-work. Arrays are list-like data structures in JavaScript. In fact, in Python, they're called lists. And as you can imagine with a list, there's a few things about lists that makes it important, right? One is the order matters. If I have a list of 10 things, well, the first thing is number one for a reason, number two is number two for a reason, etc., etc. And the second thing about a list like an array in JavaScript is it can hold basically an infinite number of things. Theoretically, there is a limit in your computer's memory about how much data you can hold, but in practice, we can just say that arrays are limitless. And because JavaScript is a higher level language, it abstracts away a lot of the complexities. So if you were someone who was used to writing C or Java, you might need to say, but every time you write an array, you might need to say, hey, let me partition off, X units of information because I have an array of X number of things. In JavaScript, JavaScript does that for us. So you actually don't need to even specify how many spaces of memory you need. You can just start making the array, and JavaScript will handle everything on the back end. So pretty nice there. Here I have a bunch of sample arrays. I can hold it. An array can really hold any data type you want. It can hold numbers, strings, nulls, variables, anything you want, including functions, and as we'll see later on, potentially also other arrays as well. Type of an array is something that actually is a little bit dangerous for us, because even though we think of arrays as this kind of like separate thing that does this really cool, has these really cool functionalities, in reality in JavaScript, arrays are actually just objects, but we modify it and we add special properties to it and we package it as an array, but in reality they actually are objects. And so if you want to figure out whether or not something is an array, type of would actually not be a big help, because when you do type of an array, JavaScript sees that as actually an object. Rather, the proper way for us to figure out whether or not something is an array is to use the array class, and it's a class because notice how the A in array is capitalized. And the array class has a function called isArray, and basically you invoke that function, you pass in whatever you want to test into that isArray function, and the output is going to be one of two possible values. It's either going to be true, which means, hey, this is an array, or false, which means this is not an array. Okay, so this is just a quick sidebar to let you know to test for whether or not something is an array. Type of doesn't really work, whereas array.isArray would be the more precise way to do it. Okay, bracket access. I think by virtue of some of the earlier workshops, I think everyone is at least very comfortable with bracket access. But essentially, arrays are lists, and so if a list has an x number of things, that means everything has a position, has a numerical position. In arrays, we start at position 0 for the very first item, and we go all the way to the very end of the list, which means that the index of the very last item in the list is the length of the array minus 1, right? Because everything's shifted over to the left one because we start at 0 and we end at the length minus 1. To access a given element in an array, line 7 and 9 there, we just have the array. We have our handy bracket notation, which we've already used when we did to read every letter in a string, and we pass in a number, and that number is going to be the position of the element that we want. So here, when we do this, we print out the first 3 elements in the array, and notice how that very last bit, I'm trying to on line 13 there, I'm trying to print out the quote-unquote 4th element, or the element in position 3 of the names array. And guess what? My array only has 3 things, right? So that element doesn't exist. But rather than throwing an error, JavaScript actually gives me back an undefined, because the intuition there is that like, well, something could exist, but for now, nothing is there, right? So just something to be aware of, and this is kind of like a particular design in JavaScript. So it's not an accident, it's actually very intentional that they do it this way. Okay, so that's how to read. And then if I want to replace any values in an array, it's almost the exact same thing, except now rather than just doing names index 0, we just add an equal sign after it as the assignment operator, and we assign whatever it is that we want into that position, and that will override what was previously at that position. So this gives us this kind of really good thing now, where before we were dealing with strings and we couldn't change it. Every time we want to make a change, we had to recreate the entire string from scratch. Now we're in array land, which means, hey, we can just change it and everything's good, right? So here's an example. We have an array and a string. In both cases, I try to change the value of the first element to a G. And with an array, it works. With a string, it stays the same, right? So with an array, it becomes Grace. And with a string, we still keep it as Brace. Because once again, we cannot change one aspect of a string after we've created it. We can only create a brand new string. Everyone good so far? That was like literally the crash course on arrays. Yeah, so we're actually going to talk about all those methods, I think, either today or tomorrow. But in all of those cases, with a string dot splice or dot slicer, you are creating a brand new string. Like, you might not see it that way, but you are creating a brand new string in those cases. You're not editing the original string. So the way that becomes really apparent when you look at like kind of the under the hood workings of a computer. If I push, like, let's say I have 4 units in my array, right? And let's say each element takes up 1 MB of space in my computer. If I have an array of 4 things, right now 4 MB of space is occupied in my computer. If I push one more thing onto that array, I now have five things. It means 5 MB of things are 5 MB of memory is occupied on my computer. If I have a string of 4 characters and each character takes up a megabyte, if I have a string of 4 characters, 4 MB is taken up. If I try to do something where I try to add an extra character to that string, that means now 9 MB of memory in my computer are taken up because I have one string of the original 4 MB and I have another string with the 4 MB plus an extra megabyte. So that's like the nitty gritty of why it's fundamentally like different when we say, oh, I created a new string versus I changed an existing array. Yeah, cool. Mhm. Hoisting does not apply to arrays, right? Like, hoisting is mostly when we think about hoisting, it just, for us for now, like, it's a very simplified version to think about it. But you can think of it as 2 ways. Hoisting does 2 things. The first thing it does is it takes all the functions that are made with a function declaration and puts it to the top of the page, right? So only functions. The second thing that it does is it actually goes through and finds all the variables, and it doesn't create or assign values to the variables. It just kind of acknowledges that those variables exist. Okay, so if I have, in this case here, right, on line 7, if I create an array with BRACE, hoisting just basically says, oh, cool, on the first pass through, it will acknowledge that the variable called array exists. It has no bearing on anything on the right-hand side of that equal sign. Yeah, yeah. I'm trying to think of a good analogy for something like this, and it's kind of drawing a blank right now. But yeah, yeah. It's almost like, like if you have a contract, right, and you edit it and you want someone else to sign it. Well, you can't just take the original contract that someone's already signed and add a few words to the end of it and have them sign it again, right? Like, you need to create a brand new contract. It's kind of like that. Maybe not the best analogy, but that's, I guess, one way to think about it. Cool. So why do we kind of put arrays in its own little category? Well, it's because arrays are a very commonly used data type in JavaScript, and they have a lot of really cool built-in features, functions, functionalities that make it really easy to use and really powerful, actually. So we're going to talk about a few of those now. The first one is something called the .length property, and this is pretty straightforward. An array .length just tells you how many elements are in the array. Okay, nothing fancy, just gives you back a number. And if you feed it an empty array, it will give you back 0. So every time you use .length on an actual array, you are guaranteed to get back you're guaranteed to get back a number that is 0 or larger. Okay. Now we're going to kind of some of the methods that we talked about earlier. Someone may have asked about, so the first one we talked about is push. And all push does is push actually adds something, adds the element, whatever value you feed into it. If I do array.push, that basically takes the value that you're pushing in and adds it to the very end of the array. So if I do this now, you'll see my original array now has James as a 4th element. And so that's what the method does. What the method returns, on the other hand, in this case, is being captured under the variable called new length on line 6. And so for that push, what it does is it adds a new element to the end of the array. What it gives back now is the new length of the array. And so here we see us pushing James on it, and what it returns is 4, which we captured in new length. And what it does is it adds a 4th element to names. A lot of times you might just see people do names.push, and that will still modify the original array, right? We just don't care about what the new length is. But the method does give you that in case you want it. So that's .push. It adds an element to the end of the array. .pop then is the exact opposite of that, in which case is it removes the last element in the array. Notice how .pop doesn't take an argument, you just call it. And the reason why it takes no argument is just because if I remove the last element in the array, well, there's nothing I need you to tell me, right? It just does it. And so that's what it does, is it removes the last element in the array. And once again, just like .push, it also changes the underlying array. But what it returns then is the element that it just removed, right? So here when I do names.pop, it actually removes the last element in the names array, which is Thomas, and it returns Thomas. In this case, we are storing that Thomas element in this variable called Jefferson on line 6. So when console.log names, we see the array now only has 2 elements, and when we console.log out Jefferson, we see that the value of it is Thomas, which is the element that we just removed. Okay, so .pop adds an element to the end of the array. .pop removes the last element at the end of the array. One other one is .shift. .shift is just like .pop, but rather than removing the very last element in the array, it actually removes the very first element in the array. And so it's called .shift because if you think about a line, right, a queue of people, if the first person leaves a line, well, then theoretically speaking, everyone else kind of moves up by 1 position in line, right? So everyone else shifts over 1. Same idea here. If I remove the first element in the array, then I change the underlying array. I take away 1 element. I return that element that I just removed, and now everyone else is kind of position-wise shifts up 1. And then what I think is the most uncreative thing ever in JavaScript, if I want to add something to the front of the array, I use something called .unshift, which just adds an element to the beginning of the array. And just like .push, when I unshift something, what the method does is it actually adds an element to the beginning of the array, but what it returns now is the new length of the array. Okay, so .push adds it to the end. .pop removes it from the end. .shift removes an element from the beginning, and then .unshift adds elements to the beginning. So those 4 basically lets you know how to add or remove things from the beginning to the end of the array. And tomorrow we'll talk about how to do these things in the middle of the array too. A few other ones that kind of help you do a little bit more search or understanding of the arrays. .indexOf is essentially a search function. If I do an array and I do .indexOf and I pass in a value, it will actually help me find the position of the value if it finds it, right? If it finds it, it will give me back the index. If it doesn't find it, like it does on line 7, if it can't find the element, then it gives back -1, which means, hey, I couldn't find a match. If it does find it, it will give you back the index of the position, but it will give you the index of the first match it finds, assuming it goes from left to right. Okay, so if I have an array, let's say the names array is George, George, George. If I do .indexOf George, it will still give me back 0 because that is the first match that it finds as it goes from left to right. Okay, so .indexOf gives you back the position of the first match going from left to right. .slice is just as is basically, you can think of it as almost like a copy method for the array. .slice takes in potentially up to 2 arguments. The first argument is the position in which you want to start, so that's the index in which you want to start at, And the second and the second argument is where you want to is the position at which you want to stop, but it does not include that particular index. So here, when I do names.slice 1, comma 2, what that really means is I want to say I want to start at position 1, which is in this case John, right? Because that's the second position, so to speak. Index 1 is the second position. And I want to stop before I get to the third element, or the position 2. Well, the third element is Thomas, and so I want to include John, but I want to stop before I get to Thomas. So basically, all I'm doing is I'm creating a copy of an array of just John. And in fact, the reason why we call .slice is because we want to get a copy of the element. We're not trying to take it away from the original array. And so if I look at my original names array, it has not been changed. It has been staying the exact same. Okay, so slice is something that we want to use when we want to create copies of something, when we don't want to change the original array, right? This is a direct contrast to the .push or .pops, right, where we're changing the underlying array. With .slice, all we're ever really going to be doing is just getting a copy of the array. And then one shortcut of .slice, if you're interested in using it, is if I just call .slice without any arguments, if I just call it like that, that's just like a shorthand for saying, hey, copy for me the entire array. Just copy for me everything, okay? And so here all we're doing is we're proving, hey, no matter what I do to the names copy array after I sliced it, I'm changing the copy of the array. The original array, names array on line 11 there, stays the exact same, right? I've basically Xeroxed the original array, and now I can do whatever I want to the Xerox copy. It won't change the original. Dot includes is just like dot index of, except it's honestly does a little bit less. This just tells you if an element is in the array. Dot index of tells you where it is. Dot include does not. It just gives you back a true or a false if it finds it, or false if it doesn't find it. So it's a less functional version of dot index of. And then dot reverse is the last one I think we're going to talk about. All that does is it, as the name indicates, it reverses the original array and changes everything from the beginning to the end. And so once again, because this method does change the original array, when you use it, just be careful. And that was a really quick recap of arrays and all the methods that we've talked about. For the workshop today, a lot of times you'll be asked to basically recreate these functions. We'll ask you, hey, can you create for me a function that basically does .shift, or that basically does what shift does, right, or what pop does. Hopefully it goes without saying, but don't use, like if the question is asking you to recreate .pop, please don't use .pop in your solution. It kind of defeats the purpose. We want you to just really get some practice on like implementing it and really seeing how it works underneath the hood. Okay. Any questions on anything I've covered so far?